let's see. We want to go from the positive to, and so we need to get rid of this for now. There we go. So let's take a look at our schematic. I'm going to go from the positive supply to R1. And then we want R2 and R3 to be in parallel. So that means that we have to connect their two ends together. And now we need to go from R1 I think, there we go, up there. Of course, I can be clever. Watch this. There we go. I mean, this is what you would do in a real one. You would to minimize the number of wires that you run. Here, I'll show you even better. So I put this here. And then I would just go like that. So now it might look a little more intuitive. And then I go from here to here. So I have the positive supply to the rail, and it goes to R1. Then it goes to both R2 and R3 at the same time because of this wire here. In fact, why don't I draw that? And so I've got the power supply, and I've got R1 and R2 and R3. See where this is what's nice. You just draw this out in your logbook, and it looks a lot nicer than what's in the lab manual. So you see these two pieces here. That's basically these two green. This, let's change this. Let's make this pink. That looks purple to me, or magenta. Let's make that one purple. All right. That was my daughter's favorite color. Although she was obsessed with rainbows when she was little. There we go. Let's see if we get any current flowing. We do. Nice. Okay. So remember, current through, voltage across. So to measure current, we have to break the circuit. So if we want to measure, say, the total current, we have to break the circuit and put the ammeter in. And big surprise, it gives us the same number, but you should never assume that's going to be true. In the real world. And it may not be always true here. So you need to check So I would advise that you let's come up with a way of writing this. Or
Professor,
yes, I'm sorry.
the
What?
colors on your resistor are different from mine. Are you using the values that are labeled?
No.
Oh.
Just remember, I'm being a stinker. Don't forget, Layla. But I'm glad you noted. Wow, I'm proud of you, Layla. Good for you. That was great. You get the gold star this week. Good job, Layla. That's really cool. Yay for me. I know, but I don't know. I just everybody likes praise. And well, so I would suggest that okay, first of all, uh you should remember that if I measure here or here, so call that 1 and 2, A1 and A2 would give us I total, huh? Now, if we put an A here, A3, by the rules of circuits, we expect A3, we expect I total, right? Why? You should, this is the kind of thing that I'd like to see in your notes. You don't necessarily have to put this in the report. So now you have two other places, A4 and A5. Now, I total and so first of all, I total and A3 have a relationship. I total and A4, A5 also have a relationship. And you can predict it and you can verify it. This is what you do when you're researching. I know by the rules of blah, blah, and there's more than one reason, right? You can say something about parallel circuits, or you can say something about all the current leaving has to come back. And the other one is the various voltages, right? So you have V battery, you have VR1, you have VR2, and you have VR3. They also have an expected relationship that you can test. So at this point, you can assume that the rules of combination are correct. You don't have to necessarily verify the rules of combination. So you say, look, I verified the rules of combination. So I expect this and I expect that. And this is why I expect it. So make sure you're saying in the mixed circuit, so I've given you 1, 2, 3, 4, 5 places to measure current. So we have 5 currents to measure. And the book and the manual goes through it too. Let's see, 1, 2, 3, 4, and 4 voltages. So you have the circuit rules, and you have the combination rules, and using them, you can predict these relationships. that I've listed here. The relationships of the 5 currents and the relationships of the 4 voltages. So what I want to see is I want to see those predictions, and then I want to see your measurements. And that would be in your final notebook, of course. What's the time? Okay. So I think we've gone over report a little bit, but well, I'm going to give you a minute to write this down because I'm going to bring up a blank sheet of paper to go over things that you should talk about in the report. Okay, so of course, just yell if you want me to bring these back. I suppose I should. Well, we do have. Now I'm thinking that maybe I should have been. What ohms value? Oh, it's in the manual, and it was in the pre-lab as well, Sarah. It's listed here: 110, 220, 330. Yeah, it's all right, Sarah. You know, you're focusing, and believe me, I'm somebody. It's part of my PhD and master's degree was about focusing. What was the current professor? Well, I don't know. I think I'm the current professor. uh, yay. You got to watch those commas, huh? I'm sorry. I'm sorry. I see it now. Currents, right? My sloppy drawings, right? It's not exactly the same as the lab manual, but the lab manual, almost the same. Look at that. What did I add in? Oh yeah, I just said, let's see, they only have 3. Right. Because give me a minute. No, see, I see better play. I see that I added this A3 here. So let's do this. Let's make my little drawing. Well, that's too much writing. You got my diagram here. So these stupid symbol. Okay, give me a minute. Give me a minute. Select. I'm going to clean this up. What do I want to do? I want to take this. I want to select all those. Yep. Oh, crap. Try again. No, now I don't have it anymore. Select. Come on. Control C. What's going on? Oh, because I'm not a mouse. And before I nuke anything, I want to make sure it pastes here. Delete. Delete. What happens? No, that didn't work. Didn't work, period. Okay. Of course not. All right, so let's do a better job here, and then so we have our circuit here. And I think I can do the rest of it off the top of my head. Let's see, huh? Let's see how good I am. And let's get this out of the way. And we'll put the chat window over here. All right, so here's what I'm telling you to do, right? We have, we can make predictions or the expected or expectations, right? Expected numbers. We can expect it, right? Relationships, which are math equations, right? So we have R1, R2, R3. So let's make a little, we're going to say that a red dot is a current measurement. So I am suggesting, no, I think what you should do is you should measure the current here, measure the current here, here, and here, and then also here. 1, 2, 3, 4, 5. So, first of all, I1 and I5, by definition, are I total, right? So there's no way you can verify that. It just is what it is. Of course, they should be equal to each other. I mean, if one of you gets something that's not equal, make sure you tell me so I can take the credit and get a prize. So now, I1 and I5, which we kind of know are the same thing, and I2, I3, and I4 all have relationships to each other. That you can predict. Using, of course, as I said, we have the circuit rules and we have the rules of combination for resistors. Now we got 10 minutes left. Okay. Am I doing a good? Am I doing all right, Carla, with what's the current professor? I think I'm addressing, yeah. Okay. I am who I am, right? Or I think, therefore I am. I am what I am, and that's all that I am. All right. I'm a big cartoon guy. I don't know if you know who Popeye is. Wouldn't that be sad? So let's say that is a voltage, although I guess this might not be. Oh, yeah, this will be useful because, of course, there is here and there's here. Oh, yeah, here's one that Yeah, that's an important one. I don't even know if that's in the manual. Wow, this is and here. So 1, 2, 3, 4, 5. Gosh, am I actually writing something that's understandable? Okay. Now, we have V1, V2. Well, first of all, the simple one is that V1 equals V battery, right? Or V power supply. That's by definition. So 1, 2, 3 by definition. That's what the 3 hash marks. So V1, V2, V3, V4, and V5 also have relationships that you can predict. So your job and the table that I've provided for you should be enough, but you may want to expand on it because I don't think it includes every blessed thing that I wrote here. Like I'm not sure about if it has volt 3, V3. So you should predict what relationship they will have. And then you measure all of them and then you could verify the predictions.